How's it going, everybody? So, in light of Tech Support Thursday, since there's really no comments on any of the videos as of lately, which is fine. You guys don't have to comment if you don't want to. I figured I would do something a little bit differently in this video where I would um, take an environment that I used to support a long time ago, and I'm gonna build it out in Eve, and it'll be our real world networking topology because it'll include multiple things. It'll include the data center, it'll include WAN in multiple scenarios, firepower, ASA, FTD, or I should say Palo FDM, meaning we'll do a single firepower device, but it'll be managed locally like an ASA would be. Then we're going to build out the core and then talk about how it's connected. And I'm not going to tell you who the customer was or what I did for the environment so that we can keep things separated in that respect. But I feel like this is going to be two different data centers. It'll be two different multiple remote locations, and it'll allow us to cover a lot of the capabilities that are necessary. So I'm literally going to build what a former customer of mine I supported for a long time. So I'm pretty intimately familiar with how their environment is laid out, and we'll take a look at that. So I'm gonna just record me going through and building this out. It's pretty much a blank canvas, and we'll zoom in, zoom out to get everything adjusted and things like that. And so what I'm going to start doing is breaking this out into two different data centers and all that type of stuff. So the idea is that we will have environments built out like so. Actually, let's put these. Yeah, that'll work. Okay, I'll go down here. So we're going to have, how do I want to do this? I haven't thought this out completely yet, but it won't be hard to get it where I want it to be. So, but I figured this would give you guys an opportunity to see me build out an environment that was a customer environment and how it was put together, the engineering behind it, all that good stuff. So let's try to get these organized like so. And so my goal at a high level is in the upper right hand, like the middle of the screen will be the data centers, right? So they have two different data centers, two different colo facilities, two different geographic locations. Then we're going to build an MPLS VPN of sorts where we'll go through and deploy a layer 3 VPN and layer 2 VPN to simulate some of the things that we did. They only utilize layer 2 VPN, so they would just order a circuit from whatever provider that they would need, and then we would just help them stand up whatever services that they needed. So that's what I'm building out. So typically the spines would sit above your leafs, but in this case here, because I'm going to be splitting the workloads and things like that, it'll make it easier to replicate this. So let's move these guys over here, and the process is pretty straightforward. It's just a matter of getting everything organized and so forth. So we're going to have that. It's going to be a little unorthodox the way that the topology is built. And I'm also, as I'm going through this one, I'm also thinking about adding in a topology that I worked with a customer where both of the topologies that I'm wanting to demo are hospital systems and different geographic areas that I've supported. So this would be the data center. So you'd have one data center up here, you'd have another data center down here. They would be interconnected to each other through border gateway. So you'd have VXLAN, EVPN. So you'd have stretched VLANs between the data centers. The spines would be connected to all the leafs would be connected to all the spines. We have a border router here, or a border switch that would allow layer 3 connectivity in and out of the connectivity. And if I zoom out just a little bit here, this topology is not going to be quite as big as the first one I was thinking of, but the thing that I'm going through and thinking about is, who's to say we couldn't do multiple real world topologies, where we'll have one is mimics one customer environment that I bring in another customer environment that I worked on, and things like that, just to highlight the capabilities that we might see and things like that. So I'm going to bring out CSR 1000 Vs, and we're going to go ahead and call 2 of these, but these are going to be the DCE for DC Edge. And we're going to go ahead and put 8 interfaces on this guy, like that. And then we're going to have these guys set up like this, something like that. And then we're going to do 2 more DCEs. And we're going to put them like that, 8 interfaces. Get that squared away. And then we're going to build them out something like that. Let me go ahead and zoom out just a little bit more. And then we're going to go here. We're going to come out with 2 more. For this side here, it's going to be CE for Campus Edge. And we're going to go ahead and do 2 more here. The 8 interfaces total. We're going to do this. And these guys will sit like this. And then behind this, we're going to have our edge. Then we're going to do 2 more routers. These guys will be 2, and these will be core. And then we're going to go ahead and trying to think back. It was distribution. So we're going to go ahead and add in, we'll say 2 more of these. And this will be our distribution. Actually, I'm trying to think back. Cancel. This is campus was switches. Distribution was switches. Yeah, so we'll just go ahead and add in here switches. We'll grab 2 of them. This will be DSW for distribution switch. Or I don't think it really makes that much of a difference. So we'll go ahead and I'll try to do 12 here. Save that. And we'll do something like this. And then we'll move all this stuff over. And then we're going to do switches. We'll do, let's do 8. This will be, I used to have the diagram of it, and I'm trying to think back of how it was actually put together. There is a server that I have in the basement that I could spin up where I have the role topology, but I don't think it's that important. I'm just trying to think back how it was built. Actually, this was named core switch. So I'll edit this. It's just bothering me that I don't have it labeled correctly. So we're just going to say core. And we'll save that there. Core switch. And yeah. Actually, I think I'm incorrect here. These aren't routers or switches. These are distribution switches. So I know it's kind of irrelevant what it actually is, but I'm like it just like I'm thinking back like that doesn't make sense. So we'll grab this, and then these two come down here a little bit further, come down here a little bit further, come down here a little bit further, and then vertical align like that, and then we'll link these guys together. So that's essentially where that would come into play. Now there was a lot of moving parts with this environment. So moving parts wise, they had a lot more going on here than even I got to see, but that's not really the important part. So what I'm going to start doing is they had a bunch of access layer switches down south of here, and I can add in like some access layer switches. So we'll do 4 of them just so that we can, even though there was a lot more than that, I think it was probably closer to 20 or 30. I don't need to have it mimic down to the that level. So we'll say ASW, and we'll say save. And so we'll just assume that we'll do something like this, and then we'll grab these two, we'll bring them down like that, and then we'll line them up. So this will go here, this will go to here, this to there, and then this to here. So these two will connect to this guy. This guy will do a port channel, so he'll have 2 connections northbound. And then one of the things that we did in this environment, which sat between the core and the edge, I really should name this edge so that it's not confusing. So E22 is we had a pair of Palo Alto firewalls that were in IPS mode, which meant that they were bumping the wire mode, and so we just did the cabling. Not me, the Palo engineer. He did his job, and then we did some configuration in order to make sure to do what we needed it to do. And so there was actually a pair of Palo firewalls in between the core and the edge, which gave us the ability of filtering at the campus level, going in and out of the data centers. So just another layer of transparency, or another layer of visibility, I should say. So what I'm going to do here is I'm going to zoom this out just a little bit more. It's going to become hard for you guys to see, but I need the space in order for this to work. So we're going to bring this down just a little bit further. And so I'll zoom in the particular areas I need to be in. So we'll start at the top here. At the top, we had these guys here. We're going up to another pair of switches. So I'll put in here just a single switch, just because. And this was the DC edge. I'll say it's DC switch. And so what we did with this one is it connected down to the edge of the routers, and then the routers had connectivity outbound to the internet and inbound to the campus. So we're gonna click on that, and then northbound of this, it had a pair of routers that would connect out to Palos and ASAs for a variety of different reasons. Now, there was parts of the network that I had no visibility to, no matter, even after 3 years of working with them. So we'll come out here and we'll do, what I'm basically going to do is I'm going to build this all out for you. I'm going to walk you step by step through all the things that we did. And then I'll take you through how to shore up. And I'm actually missing some pieces here that need to be added now that I'm thinking about it. Because they had a legacy Nexus 7K, 5K design, that was your traditional. You had 7Ks and you had 5K, or sorry, 7Ks and 5Ks. Yeah, 5Ks that were meant for their old distribution or data center, excuse me, and there was connectivity into their VXLAN environment, and so they actually had two different designs going on at the same time. So I actually need to think about that too, and I'm thinking back through what that looked like. Because I used to have a diagram readily available to me to look at, and I don't anymore. But it's not really that relevant. So I'm just trying to think back through what all stuff do I need to add to this environment to make it look like it used to. And that's the part that I'm 9 months removed from working in that customer's environment, so I don't remember all the specifics. It would take me probably about a month to get reacquainted with them. But trying to think here. Yeah, because Yep. Okay. Now I'm remembering. So it was 7Ks, but it was N7K, and then we're going to drop out 2. This was their core, and we're going to go do 12 of those interfaces, and they'll be sitting right here. This was their core, and then they had 2 more. It was technically the same chassis, but they were 2 different VDCs, 2 different virtual device contexts, and N7K. And we're going to do 2 here, 12 interfaces. So it was like something like this. These guys were connected to each other like this. And we'll move this. That's okay. Yeah, that's starting to look better. It's like there's something missing here. So we're going to actually take all this stuff right here. We're going to slide it over this way. This way here, there's room down here at the bottom for some of the stuff. And if I'm not mistaken, I think, yeah, these guys were sitting over here. That makes more sense now that I'm looking at it again. So, like I said, I'm trying to rebuild it from memory, and I feel like I'm pretty close. So this, you had for clarity's sake, actually, what I should really do is delete these guys and do 7K core, 7KC, and 7KD. That would make more sense. Let's just go ahead and delete those. So why does this matter? It really doesn't, but it's more or less my OCD is triggering, and I'm like, well, that wasn't actually how it was set up. So 7K core, we'll give it the 12 interfaces, save that. So this is when I'm, even when I'm working at a customer environment, this is what I'm trying to mimic. This is why I had dedicated servers for these bigger environments so that I can deploy EVE-NG bare metal. And we'll go 7K distribution we'll give it to 12 interfaces. And we'll bring these guys over like so. Pretty sure, and these guys were actually connected to the border gateways through a back-to-back VPC, 10 gigabit. And we, once I discovered how their environment was laid out, because I was troubleshooting a multicast issue with them for a long time, probably close to a year. And one of the things that I did was I got down to the brass tacks of, okay, I wanted to make sure every interface from point A to point B had multicast enabled on it, so PIM was turned on. And that's how I got down to the interface level. And eventually I figured out what the problem was, but it was just one of those things where as you're going through and you're troubleshooting, that's the level you have to get to sometimes. So we'll go ahead and do a couple of regular switches here. We'll say 2, and we're going to say DC switch, just so that they're there, and we'll do a VPC to these guys, something like this. Some of the names I'll redo just because it'll make more sense later on down the road, but for right now it gets the point across. So that's essentially how that was lined up, and then the cores, I don't know why I moved that over there. My OCD was triggering. So then these guys would connect back here. Yeah, that's more accurate. Let me move this stuff over here more so it's out of the way, and I can move all this down and move this down, oops, like that. That's better. Okay, so what'll end up happening is down here at the bottom, I'll have to add in some more equipment. So these, no, actually no, it was over here. So these 9Ks were connected to a pair of palos. So that's the next thing for me to do, is add in a couple of palos. So we're going to say 2 palos, 2 PAs. And these had 8 interfaces. Well, that's at least what we're going to give them. And we're going to say, and then these guys here. It's actually kind of fun rebuilding this, because what one of the things that we were doing before I ended up not being a support engineer for them anymore was, because I ended up leaving that company to go to work for the one that I do now. We had spent a significant amount of time on their data center re-architecture and redeployment. So we were in the process of changing a lot of logical things. And that's one of the things that I talk about quite a bit on the channel, is that 80-20 rule, where I was spending a lot of my time digging into how to make all these things work. So I was literally building out what you see here on your screen in a virtual environment, minus, this stuff over here didn't matter as much. But I would go through and get all these things stood up, configured, working. I would mimic their environment as much as I could, so that when it came to testing time and I was making a change, the change that we were suggesting be made, I would do it ahead of time. So I knew about the effect of it before it became a problem. And I realized the problem with the design as soon as I made it. And I said, okay, the only way to fix this was to do this instead, go to BGP. And then they were apprehensive of that, and rightfully so. It's a big change, changing their routing design. And it was kind of funny, because the engineer I took over for had made the suggestion like 3 years prior to that. He'd been working with that customer for a long time. And when I went to him and said, hey, this is what I'm seeing, he and I hopped on a call, and he was just like, yep, that's exactly what I suggested to them at the time. They were like, timeout, that's too many changes. There was some political stuff going on I won't get into. But long story short, I was just like, okay, the only way to fix this, at least the way that I'm seeing it, by doing a peer review internally with what I've got going on, is we need to change your routing around, and so that traffic will go the direction we expect it to. And it was like, okay. So as soon as we made those suggestions, they started putting the brakes on the changes, because they were more invasive than what they were comfortable moving forward with. And I understood that. It's a hospital. It's a level 1 trauma center. So long story short, that idea was cut short. And I'm going to go ahead and add in here a single switch. I'm just going to call this ESW for edge switch, and that's what connected the palos to the internet routers. Let me go ahead and zoom out. I know it's hard for you guys to see this, and actually I can get out of the way. while we're doing this so you guys can see it like I do. So we have these guys connecting to a pair of edge routers. So another pair of ASR1Ks. We're going to come over here and do 2, and we're going to put in here ER for edge router. We're going to put in 8 interfaces. Save that. So we're going to bring them guys over and handle that like so. And then these guys, ironically, had internet connections themselves. Actually, I could probably bring this down just a touch and do something like this instead. And this is where HSRP was coming into play on this edge. So it might be a little challenging for you to follow considering there's no links attached, but I'm going off memory. So we're going to go ahead and up at the top here, actually I might have to zoom out just a little bit more. Yeah, let's do that. And let's bring this down just a touch. We're going to go ahead and grab in some more palos. And we're going to go 2 of those, and we're going to call this, I forgot what I called the other 2. We're just going to call those edge firewall, for the lack of a better term. Give it 8 interfaces. Change it from VNC to Telnet. Save. And these guys are up here doing the same thing. There was actually an ASA firewall that we had to make some changes to that wasn't included in this, but there's certain things that I don't really care too much about adding into this topology because they're kind of irrelevant. So the idea here is to use the right side of the topology to do all the remote sites. And because there were some sites that were directly attached to these guys, and some sites that were attached to this border router. I know you can't see that on the screen, but we're going to go ahead and grab, let's see here, we're going to go grab palos. We're going to grab 3 more palos because they had 3 remote sites attached. We're just going to call these firewalls. Give them 8 interfaces just because we can. And we're going to connect them like so. They had both internet connectivity and private WAN back to the border router. So I'm going to go ahead and we're going to grab just a regular router. We're just going to call this iNet. And we're going to go grab 8 interfaces just so we have enough. Save. I want to do an MPLS VPN here. I don't think it's really necessary. We can just, shim this together. And I know you guys can't read this because it's too small, even for the screen. I'll zoom in here in just a second. But I'm just thinking of the routing piece. I actually needed to go in here. Stars. We'll give it 8 interfaces just to be good. And then we're going to have this. And then this will allow us to test out the internet. And then we're going to go grab another router here. This will be our router. We're going to call this MPLS. Or actually, I'm going to call this WAN. And then we're going to bring this on top. And then on the inside of these switches, 1 for each site. Even though there was more, that's kind of irrelevant. And then we're going to set this guy here, this guy here, and this guy here. Now all the palos will have to go through and set up management connectivity too. So let's go take the next few minutes and we're going to start drawing this out, drawing connections to each other. So this will start to make more sense. So just so you have an idea where I'm coming with this iNet router, these 2 routers here will connect to this guy, and then I will draw links to the firewalls and all that type of stuff. So I'm going to need 1, 2, 3, 4, 5, 6, 7. So what I'll do is I'll do network. This will be management. It'll be a cloud, and it'll be management cloud, and I'm going to do 5 of them. We're going to save. I don't know where they're going to pop up. There they are. So we'll give 1 to this guy. Then we're going to have to do this. Another thing too is let's go ahead and grab. I'm going to go grab another router up here. Node. There's supposed to be a way to do like intra-lab stuff, but I don't think I've ever figured that out. We're going to call this inet2, and we're going to grab 8 interfaces. And where did he get dropped? You know what? Maybe he didn't get. Oh, there he is. He's way over there. Okay, so I'm gonna drag him all the way over here, and then there will be a connection that goes from here down to here to connect the internet together. So we'll put him down here like so, and then we'll grab each one of these guys. There will be a come here. I hate how they don't grab when you want them to grab. Okay. So let's go ahead and zoom in here a little bit just so that it's easier for you guys to see what's going on. We're going to do the data center first. So this is where you'll have to do a little bit of, we'll start there with L5. And this guy will connect like so. We'll stretch these out as we need to. But this is what I would do in my spare time when I worked for this when I was working with this customer, because that's what was needed for me to be able to do my job. This is what I had to do. So was it a little over the top sometimes? Yes, but that was part of the expectation this customer had for me, was to go through this level of effort to make things were working correctly. So was it extra effort? It was, but I wasn't about to sit there and complain. I actually enjoyed the work. So it was a lot. But I figure seeing me build out a lab and explain what's going on each step of the way is important, so that you guys will understand the mindset of how I went about doing things. Even though this is definitely more like a obsessive compulsive, I'd rather be referred to that and very thorough than otherwise. So I'm going to go ahead and get that one knocked out too. So the other thing that I like to do when I'm building out these is I like to stretch things out so that they all line up. That's another part of my OCD thing that I wish I could get rid of, but I don't think I'll ever be able to. So in other words, I would want to do this, grab all these guys and drag them up here so that they're all lined up accordingly. Oh, well, that didn't work out the way I wanted it to. Delete. I wanted them to connect to here too. Okay, so I wanted you to connect here. And then this guy. Well, actually, no, I take that back. No, I wanted you to connect there. And then this guy here will connect to this guy. I think it looks better when the lines are all straight. That's just my personal take on it. But, you know, to each their own. And then I'll have to interconnect all these switches together with VPCs. And it's a little a little monotonous, so I'll do the same thing here. We'll do the spine 3. But this is the time that was spent on this customer environment so that when it came time to do the actual work, you already had everything figured out. It was putting the documentation together, the Word docs, and having all that information directly available to me. That became huge. So, and I think that's what kind of separates an engineer that's just doing what they got to do to get the job done to taking it to the next level and having that trusted advisor type of thing. Because after a while, the engineer that I took over for, I don't remember how long it actually took, but let's say it took 6 months. It took 6 months for the main engineer of the customer to stop asking me, what do you think so-and-so would think? Have you talked to him about it? I'm like, I haven't, but I can. And then so I would ping him internally and be like, hey man, do you mind if we have a chat about so-and-so? And they're like, yeah man. So just find some time on my calendar. And so we would chat. And the funny thing about it is, what was supposed to be a 30-minute conversation ended up turning into typically like hour and a half, 2 hour calls. Because, A, we got along really, really well. And it was one of those things where, both CCIEs, both hardcore network engineers, stuff like that. So we would spend quite a bit of time talking with each other, and we just generally got along really, really well. So it's a lot of the same things in common. So I miss a lot of the dudes that I used to work with. I shouldn't say just the dudes. There's a lot of really talented engineers that I would work with. And did I just double link that? I did. Did the same thing again. Like that. Oh. Need to have my back adjusted or something. Too much time sitting. So I'll take this piece here and I'll bring it down just a touch so that I can stretch this stuff down like that. That's a little better. Now I can zoom back in like that. There we go. All right, now we're cooking with fire. So, and the BR, the border, was a device that we added in after the original deployment was done, because we were having problems with routing on the border gateways. Because every one of these connections was a VPC for high availability, and we were running into problems with that. So funny story is these guys are actually connected to each other through a layer 2 link, but since I don't have that built, I'm just going to draw those two together like so. And we'll bring this one closer just so that it lines up better. And like that. Even though I should have done the VPC first, it's whatever. I can always change the connections later on. But what I'll do is I will adjust this stuff over just a touch, because I like things to line up. My OCD gets triggered when things don't line up. So I'll draw the VPC connections together real quick, just because we're right there. Now this would take me a while to cable up. Now just imagine me waiting for each one of these devices to boot, save the config, and get everything up and running, and the time and effort that it takes to do that. So I would sit here if I didn't have any pressing issues, I'd sit here this would probably take me a day and a half to 2 days to spin up. And then what I would do is, as I was configuring things, I would be getting everything stood up, configured, and then saved, and then adding the configuration in that was necessary. So you would do this in an effort to try to, if there was a problem, I always had I'd export the config off the device. So if I ever needed to pull it, I could always grab it in a moment's notice and be good to go. And a lot of the times I was pulling the config, all the relevant stuff right off the actual production equipment. You just do a quick show run and pull off the relevant pieces and dump it into my lab. And anything that wasn't necessary, I would just clean up after the fact. But so the idea here was, and this is the part that always confused me, was the Palos were always in HA. So we'll grab this one here right away. And then I'll connect the management interfaces real quick. Horizontal align. Where did that guy go? Oh, I hate when it does this. I absolutely cannot stand when Eve does that. I think it's like, really? Why did you do that? I don't know why it does that, but it is what it is. So we'll grab these interfaces real quick. This will go to management. So I know someone's going to ask, was the things that you were doing for this environment necessary? Technically, no, but I didn't want to guess at anything. I wanted to know for sure this is what was needed in order for this particular thing to work. So if I remember correctly, it was that to there. And then this one here, I think. Yeah, because you'd have overlapping subnets if you weren't careful. Yeah. So 7 and 7. This would be one subnet. This would be a different subnet. And then we would do the same thing here. Nope. We'd have to do, this would be 1.7 subnet would be here, and then 1.7 and 1, yep, that'll work. So you might be like, what are you talking about? And I'll explain here in just a second once I get it cabled. And then that should be, I think that'll work. So what was happening was, you can't, in the same subnet, or inside the same VRF, you can't have two interfaces with the same subnet because you use the recursion process in order to figure these things out. So what you would do instead is, and I'll grab a text box here, is the Palos would be in HA. So 45 would be active, 46 would be standby, right? Go ahead and zoom in here just a little bit. So what you would do is you would grab, say, this address, and you would do 10.15.45.0/24. Okay. You would do this. That would get applied to that particular interface. And then what you would do is you would duplicate this over here. I might have to, can I edit style? Link label, there we go. 10.15.45.0/24. Okay. Yes. We're going to save that. We're going to go ahead and get rid of this. This will make things a little easier. So we would also have, we're going to edit style. This one here will be 10.16.45.0/24. Even though in reality it would be /30s or 31s, we're going to sit there and bring this down here like so. Okay, so what would end up happening is we would need to mimic this addressing scheme over here. So these interfaces would have to have the same subnets, right? So 1/2 here would be, have to be 1/2 here. But what you couldn't do is you couldn't have 10.15.45, oops, yeah, that's correct. 10.15.45 here and 10.15.45 on 1/8, because that would be overlapping subnets. So you'd have to use different interfaces. And so what we would do is on this guy here, you would do edit style, and you would do a 10.15.45.0/24, and you would save that. And then you would do here, you do the exact same thing. You would edit style, you would do a 10.16.45 .0/24. And if you're looking at it kind of crazy, like, well, hold on a minute, Rob, this is going from 15 to 46. That's true. But with HA, you have two different devices that are synchronizing their data over E1/1, and because they're doing that, they're actually the same configuration on both devices. So you couldn't do that at the same place. So if we were to go here and move this down to there, we're just going to go ahead and save that. And what I'm going to do is I'm going to stretch this out just a little bit just so that it's easier for us to see. Just like that. Line these up here in the middle again. So E17 on border gateway 15 would have 10.15.45.0/24. But in the event, and E13 would have 10.16.45. And if you notice, actually I think I just screwed up. They need to be the same interfaces on both, or actually no, I'm sorry, they can't be the same interfaces. They have to be the same interface configurations on the Palos. But on the border gateways with the 9Ks, you don't want them to be the same interfaces. You technically could. So you want to make E17 to connect 1/2. This one here is going to be 10.15.45.0/24. As long as E12 on this side is also configured for that, you're okay. So that's why the failover is important. But you have to have the same subnet. But you couldn't have 10.15.14 configured at E1/8 on border gateway 15, because that would be an overlapping subnet inside the same VRF. So you need to put it on this interface here, or on this device, on this interface, so that the capability would flip. So that you would always flip-flop the interfaces so that the capability would work the way you need it to. At least I think it would be okay. I'm trying to like run through my brain here if this would work the way that I expect it to. And I'm 99% sure I should be okay. So I think we're going to be fine. So yeah, we're just going to roll with this until we can't. And we'll deal with it at that point in time. Now, will I have to manipulate some of the spacing of these devices? I will. But that's why I like the labels here on the devices so that it's obvious to what it is. So that's a 10.15, 10.16.45. That should be fine. And then this one here is 10.16.45. Yeah, that should be fine because it'll be border gateway 15 and border gateway 16 that would have active eBGP peerings to Palo 45, but you wouldn't have anything on Palo 46 active. The interfaces should be down in that particular case on E18 on both. So what would end up happening is if Palo 45 for whatever reason went down, we shut down the interfaces on the Palos or whatever. We shut down the BGP peering between border gateway 15 and 16 and Palo 45 and then brought them up on 46. Some sort of a failover event. Well, you could do that and the job would get done. You just have to be cognizant of the fact that you can't have overlapping address space. So we're going to go ahead and drag this down here like that. Is it time consuming? It is. It is time consuming, and that's par for course. You know, you're keep in the back of your mind all the things that you have to keep in lockstep as you're doing a deployment of this size and this type. There's a lot that goes into it. Would I normally do this the same way? There's easier ways to do that. You would configure a VPC or at least a port channel on the border gateways, and you would configure an aggregated Ethernet connection on the Palos. The virtual Palos don't support that, but the physical ones do. and you would go through and set that up accordingly. So you would do a SVI over the port channel and the VLAN or a sub interface, and go about it that way. But we'll walk through all those things and see exactly how that process comes into play. I'm mimicking a customer environment that I used to work with. So is it going to be identical? It's going to be close. Be very, very close. But the whole point here is to walk through real world scenarios that I used to see on a regular basis. So we're going to connect this guy here to the internet. And do the same thing here, because that's literally what it is. It's internet. And go through and get all that stuff situated. I'm going to move this guy up here just so I can get this in line. But what I'm going to do is, after I do this, I'm going to go ahead and edit style. I'm going to change this to be flowchart. State machine. No, I don't like. I can. No, they don't. Too bad they don't. Oh, midpoint. There we go. Position label. Yeah, there is no label here. Too bad they don't. Solid dashed. Yeah, I prefer solid. But then you can always change the link color if you wanted to. Cancel. Midpoint. That works. And I'll do the same thing here. Oh. My back. Anyway, this is some of the stuff that you would have to deal with as an engineer. And we'll go to flowchart. Yeah, that's fine. And then we're going to do one more here. Well, this guy, he won't go any further that way, so I'll make it happen. So we're just going to go do that. And we'll edit style. We'll go flowchart. Save. That lines up nicely, so we're in good shape there. And then for WAN connectivity, we will connect him to this like so. And then we will actually, if I remember correctly, they were using layer 2 VPN interconnection, so they would order a new VLAN. So I'll basically do the same thing. I'll just create a new sub interface on E13, and we will connect these guys together like so. This will be E1/2. And then like so. Is it a lot? It is. But this is going to be some fun. It'll be fun. I really should be using a switch for this device, but it is what it is. Because you're probably thinking, like, how are you going to pull that off with sub interface to this guy? Well, I'll figure it out. If I have to put in a switch, I'll put in a switch. No harm, no foul. So that's at least that part of the connectivity. And then these guys here have connectivity to this guy. A lot of high availability in this environment, obviously. But that's part of the fun, right? At least to me, anyway. And we'll go ahead and get this all squared away. And all that good stuff. And then these guys will connect up to the other side. Alright, so that's looking a lot better. We could even do something like this where we scoot this stuff over here a little bit so that it's a little easier to work with. Yeah, we could even move this stuff over just a touch more. Grab There we go. That's a little cleaner. And then what we'll do is this guy right here will connect to here. This was also a layer 2 VPN, by the way. And this guy here will connect to this guy. You guessed it. And that's how that was all plugged together. And then for the top here, this guy here would connect to this guy, and this guy would connect to this guy. So it was, no matter which way you're coming out of the campus, you could go to DC1 or you could go to DC2. We call this something else, but for the sake of keeping things simple and easy to follow, it makes sense. So we're gonna do that like so, and all that good stuff. So we'll go ahead and add in a couple of more switches in here, just so that they are DC switch 2. And grab this, put him there, put him there. These will all be VPC configured. So there's that. So the question is, where do I go from here? I'll just zoom in on this section here, and we'll get this knocked out because it's not that difficult to get all this wired. We're going to put these guys together like so. These won't be VPC'd, even though technically they were. Or I'm sorry, no. The only thing VPC was down here, and we'll go ahead and get that squared away. But I want to at least get this piece done. And all that fun stuff that goes along with it. So we'll grab, the spines are already in place. That's good. Lots of redundancy. They have redundancy everywhere. It was a good, overall, it was a good design. I'll never knock their design. A lot of thought was put into it, but it just became a little much sometimes. I do remember another engineer trying to take over, and it was challenging for me to be the main person on this account. So as the network guy, because there was just so much more for me to look at. But you know, it's par for the course, I guess you could say. Let's move this up. That's a little better. Move this out and out. I like things to be a little bit more lined up, if you couldn't tell. So, oh, that's better. Cracked my back right where I needed it to be cracked. So, good stuff. All right, I'll save that. And then these guys are VPC'd. So one of the common questions that I get, well, I used to anyway, is if I'm in a VPC design, how do I migrate from A to B? How do I get my default gateways off of here and put them over here? And the simple answer is you set the VPC up, you do a back-to-back VPC between these guys, which I'm going to show you guys how to do here in just a second. And once that's stood up and everything is working, then you can go ahead and facilitate that connectivity. You can do the VPCs, do the port channel, and then you can shut down the SPI here, enable the SPI here, and advertise that subnet from this guy instead of this guy. That's really all that comes into play with that. So pretty straightforward stuff, but if you've never seen that done before, I could totally see why that would be a pain in the butt to deal with. So one of the things that we ended up talking to the customer about doing was, in order to move from, get rid of the 7Ks and the cores and the 7K distribution and get rid of them, and go. We were trying to get them to go directly to the Palos via BGP for internet routing. That's what we were trying to get them to do. But no hospital system is ever going to be that quick to move. So it's one of those things where you just have to be patient. No pun intended. So, all right, we're at the hour mark, and I've done a lot of the cabling. So what I'm going to do is I'm probably just going to let this go, and you guys will be able to see this later on. But the subnetting wise, we'll do /30s. I was using the /24s for reference, but this topology is big intentionally. So be aware of that. And so what I'm going to do is I'll get this last little bit of cabling done, and then I'll show you guys how to do the back-to-back VPC. It simply just links between the two. And I'll show you what that looks like. Hopefully it'll work the way that I want it to. I don't know yet. Alright, so what they ended up doing was they did something like this, where they had the cables ran between the two. We saved that, and that's hard to, it's kind of ugly. So we come over here, we go to edit style, we go to flowchart. Oh yeah, it's not gonna let me do it the way I want it to. Can we do Bezier? No, it's not gonna work out. Straight state machine. Let's save that and try bringing these down just a little bit. Yeah, see, you would run the cables like this. Let me bring this down just a touch more. Right, you'd have it lined up like that, is what you would do. And we'll go ahead and do, come on, edit style. We'll do flowchart. Oh, that'll work. It's more obvious. What about this one? Edit style. Flowchart. That works. That's a little better. Midpoint, we'll bring this over here. That's more, there we go. Okay, that works. And then we'll do this 1.8. We'll bring this further down. That works. We'll save that. So then the port channel, we'd have a back-to-back VPC configured on 1.9 that would connect down to these 7Ks, and we go with it that way. All right, so that's basically how that would come into play. I'm going to work on getting the rest of this cabling done. I have quite a bit left to do, but as you can see, once you start getting it together, when we start drawing boxes around stuff, it'll become much more obvious as to what it is that we're trying to do. So anyway, that is it for this video, and I will catch all of you guys in the next one. Have a good one, everybody.